Okay, I've been asked to do a problem like this, and the question that's being asked that you can't see is that you have four solutions right here. And it is asking us, there are four solutions of the same volume, and so they're asking us here to predict which is going to be the strongest acid, and we'll label that a 1, the next strongest a 2, the next strongest 3, and finally the weakest 4. And so how would you tackle this? Well, the way that I would do that is to recognize that if you have some acid, HA, okay, and we combine that with water, plus water, then if it's a strong acid, it's going to go completely to the right and form A minus plus H3O plus. Alright, so if it is a weak acid, we know that it's going to be at some equilibrium right here. And so the acid part of this is the H3O plus. This is what is doing the work here. That is what is going to eat things if you want to etch. It is that H3O plus. And so if you have a lot of H3O plus, then you have something that's very acidic. If you only have a little bit of H3O plus, then you have something that is not quite as acidic. And one way we can estimate this is by writing a Ka. Okay, so Ka is going to equal the concentration of H3O plus times the concentration of A minus divided by the concentration of HA. Oops, HA. Okay, so that's HA down there. Alright, so this is our Ka, and so if there's a lot of H3O plus that we put in here, then that's going to make Ka really, really large. Okay, and so if there's not as much in there and you have more HA in there, then you'll know that you have a weaker acid. And so the larger Ka is going to give us a strong acid, and the lower the Ka, the weaker the acid. Okay, so let's look at these and let's deduce a few things. Alright, so in this first one there is an HA right there. You have to sort of know what this is at times. And you can see that, well, we have right here the A. Alright, we have some water in here, right here. And then we have our H3O plus. Alright, so that's half the battle, is figuring out what they're asking. So the whites are definitely hydrogens, and the red is the oxygen, and then this off color is going to be our HA. It's going to be the A of those. Alright, since these are all in equal volumes, then what we can do is just fill in these things. So for solution 1, I'm going to calculate the Ka for solution 1. Ka for solution 1. Okay, let me count up the number of H3O pluses. I have got exactly 1. Okay, which means I have exactly 1A. Okay, so 1 times 1 divided by the number of HAs. I have got 1, 2, 3, 4, 5. Okay, so I have 5 there, and that's going to equal 1/5. Alright, so I have a Ka for solution number 1. Let's look at solution number 2. So Ka of 2. Alright, so I have, I see my hydronium, my H3O plus. I see my A minus right there, and I see my HA right there. So let's just go ahead and count these up. Okay, so for the H3O plus, I count 1, 2, 3. Count 3 of those. Times, it's going to be the A minus. Then I see, for the A minus, I see 1, 2, 3 of those as well. Divided by the HA, I've got 1, 2, 3, 4, 5. So I got 5 that I count there. 1, 2, 3, 4, 5. Just double checking. Okay, so when I do that math, that's going to give me a Ka of 9/5. Okay, let's calculate the Ka of the third solution. Alright, so it's going to be H3O plus. I see that I have 1, 2, 3. 1, 2, 3 of those. So that's going to be 3. Okay, times the A minus, I have got exactly 1, 2, oops, my pen went crazy on me here. Got exactly 3 of those. Okay, so I come over here, and it's going to be times 3 of those. Divided by the HAs, I have got exactly 2 of those that I see over here. I've got 1. I've got 2. I've got 3 HAs right there. Okay, so that's going to be 3 times 3 divided by 3. And so my Ka is going to equal 3 right there. 3 times 3 divided by 3. Do 3. Just making sure I did that right. Okay, and let's look at the last one, the Ka of number 4. Again, count the H3O pluses. I have got 2 of those. Okay, I've got 2. I've got 1, 2. So that's going to be 2 times, count the A minuses. I actually see 2 of those as well. 2 times 2 divided by the HAs. Again, you should be able to see where the HA right here and right here is going to be 2. So it's 2 times 2 divided by 2, which equals 2. And so let's compare all of these different Kas. The largest one that I see is right here. So 3 would be number 1. The next highest I see here is in 4. That would be right there. The next highest one that I see is right here. And then finally the last one is going to be right here. So this would be 1, 2, 3, and then 4. So that's how I do those problems. Just calculate a Ka, and that should tell us which one are the strongest and the weakest acids.